Okay, well, welcome everybody, and thank you for joining us today. We appreciate your joining us to learn about the 2024 Google Summer of Code projects. And now on to our first speaker, Adarsh.
Greetings, everyone. So, I am Adarsh Rawat, MCA student from India, and I have worked on the P4 compiler documentation project. It was mentored by David Iscano sir and Fabian Ruffy. So, the challenges that we faced during these projects were the mobile usability of the documentation, along with the need to build documentation, outdated documentation, and lack of testing for documentation. We came up with few solutions for them. For the mobile usability, we are using Doxygen Awesome CSS along with Doxygen, which allows us to generate documentation which is mobile device friendly. As you can see the difference between both of them. Also, there was a need to build documentation locally when the developer need to access all the details, and the details were spread throughout the repository. So in order to fix this, we created a GitHub workflow, which on changes triggers a action that combines Doxygen along with Doxygen Awesome CSS and generates documentation for us. For the third issue that we had regarding the outdated documentation resources, we had to first clean up all the resources and made sure that all the links were properly working, along with syntax correction for Doxygen, as Doxygen was already configured for the website, but we needed to improve it. And there were a few UI improvements also, like we shifted to SVG diagrams. Before we used PNG diagrams, but now we have better quality of diagrams on our website. Also, there was a lack of testing for documentation changes. So I introduced a new GitHub action workflow, which allows us to preview all the changes before actually merging it into the repository. This makes sure that nothing breaks during the documentation or during any changes. So these are the solutions summed up for you. Like for mobile usability, we used Doxygen. Doxygen was already configured, but it was obsolete. So we updated to Doxygen 1.12.0, which is the latest version of Doxygen. It involves a feature where we can hide the comments from the GitHub while actually using them for the Doxygen generated documentation. So these are the outcome of the website which we created. It supports dark mode along with mobile friendly devices. So what are the future steps for this project? As we all know, documentation is an ever evolving plane that evolves along with the project. So the future steps involves that all the contributors update the documentation along with the changes so that all the contributors can get the latest changes. Also, if you have any doubts regarding the documentation, you can check this QR code. Like you can scan this QR code and access the documentation website.
Well, in the meanwhile, I can ask a question to Adarsh. So, in your opinion, which are the benefits of having a clear documentation for DP4C? I mean, how the community benefit of this work that you did during the GSoC?
As you can see here, all the changes that, all the things that are listed in this sidebar, they are actually spread throughout the repository, and it can be difficult for a newcomer to find them. And our homepage also features a getting started section where all the starter guides are provided. I have also added contribution guidelines for new contributors, along with usage instructions for Doxygen and comment style that should be used. We previously didn't have this, so it was difficult for new contributors to actually understand how to get things done. It is obviously easier for someone who is already working with P4C, but since we want new contributors to also take part in our repository and contribute code, so it is important to have a documentation site where they can actually learn about P4 compiler. Also, this documentation was not available on website. We had to build it locally. And for a new contributor, it can be difficult to actually understand how to build documentation locally on their first go. So this provides them with a head start so they can start contributing as early as possible. Here is the Easter egg for the website. If you click on the icon, you can see that there is an animation that goes on. You can check it out on the official documentation site. Initially, the diagram is static. If you click on the P4 compiler logo, then it starts to animate. Just a Easter egg, might add few more. Thank you for your time.
Thank you. Nitish?
So hello everyone, my name is Nitish. This summer I've worked as a Google Summer of Code mentee at P4. So I worked on building a code formatter for the P4 language. Billy and Fabian were my mentors who helped me and supported me along the way. A little bit of introduction. So I'm Nitish and I'm a final year undergrad at IIT Kharagpur. I'm a huge open source enthusiast and I love contributing to open source projects. I've been doing it since my second year in college. Some of my contributions which I am rather proud of are in Rust core utils, Nixos and Spack package manager. My primary interest lies in compilers, networking and distributed systems. I've also worked as a Linux Foundation mentee, which was just before this GSoC period started. This is my GitHub account. So if someone wants to take a peek at it, you can do so. Uh, I play badminton in my free time and also play tabla, which is sort of like an Indian musical instrument. Although I'm very bad at it, but still I do it. So, as I've already stated, I've worked on building a formatter for the P4 language. So now there are two components which is very essential for developing a code formatter. The first one is a front end that can pass the source program into a sort of abstract syntax tree, and then other one is a pretty printer which prints the CST by traversing it. So fortunately, we already had both of these, but there were some issues with it. The first issue was that it didn't have any comment information in its AST, so it was all stripped away. And we know comments are very essential part of a good formatter. So without dealing with this, no way we could have proceeded further in the project. So this was kind of like the central thing which needed to be dealt with first. The second problem was that our pretty printer had basically zero formatting option. So it was very simple. It just traversed the IR nodes and printed the source. So my objective were to first modify the AST such that the comments get attached to the proper nodes. Now this seems kind of like an easy thing to do, but a lot of projects suffers with this issue of attachment of comments to node. There's a project called Go for Matter which has this problem where due to suboptimal like design choice, they had to suffer with a lot of problem. We'll discuss some of these problems in our next slide. Since we have already just started building a formatter, we have a lot of time to experiment and come up with a good design. Yeah. The other objective was to build some common formatting options like line wrapping, indentation, and stuff. Unfortunately, this wasn't achieved due to lack of time. So overall, I had to build a minimally functioning formatter. So our initial plan was just to go ahead with GoST, whatever GoST was doing, and build things on top of it. But this idea was discarded since it suffers with some problem. So the Go formatter currently stores all the comments with their position information in a file. It doesn't attach this comment to the node. They go through the code, nodes and the comment list together, and based on their relative position, the code is printed. The source code is printed. So if we arrange some of these nodes, the comment no longer points to the same node, which leads to improper attachments. So there are a lot of concrete example which you can go and check out on GoST issues page, which arises due to this problem. Now, our implementation was inspired by how puzzle tools like Gazelle preserves comment. So we currently Lex and store all the comments found in the file as a global list of comment, which is part of input sources class in our case. Now, we also have a separate comment class to store the comments related to each node. So the comment class is part of every node. Comments are of two type. A prefix comment, they are independent sort of single line or multi-line comments before a particular node or code construct. And there are suffix comment, which are trailing inline comments after a node. Now we go through two separate passes, a pre-order pass and a post-order pass, to attach both of these, all the comments to the nodes. So each of this node have a start and end position, and the comment has it too. Both has a start and end position, right? So we follow a rather simple approach. We make use of the position information of the comments and nodes, and go through the comment and attach the independent line comment to AST node right after it, in a pre-order traversal. And similarly, we go through it, the inline trailing suffix comment, and attach it to the AST node right before it in a post-order traversal. So as we can see in this code snippet, the line comment got attached to the struct, right, and the suffix comment got attached to the Ethernet type. Now to do this, we were using two vector which were prefix and suffix comment. Each of these added a little bit of extra overhead to the compiler, and this might have potentially slowed down the compiler or increased the memory consumption. So we decided to switch to a local side map, which the each P4FMT uses, a P4FMT being our format, which stores the node ID along with their associated prefix and suffix comment. And when on the second pass, when we do the second pass while printing, we reference this map to print the comments. So this is an example of the result of our approach that we took for attaching the comment. I have included only a snippet because of the lack of space. So on the left side, we can see the source with the comment stripped from it. This was the behavior before the project started, and on the right side, we can see that comments are getting attached properly to their respective nodes. I sort of also worked a little bit on developing a reference checker for this formatter, which utilizes the Golding testing principle, wherein we define our expected output and we try to get closer and closer to to that output. And these are some related PRs of my work. Now, our approach currently doesn't solve a lot of problems, right, which a proper formatter should have. For example, as you can see, the free floating comments, right, the comments which are not just before or after a node is rather, which is rather far away from both of these, are not handled properly. It is not attached currently. So a rather simple approach would have been to deal it with in a either pre-order or post-order pass, attaching them to the closest next node. But there was a lot of edge cases that need to be handled, and our solution didn't seem appropriate to deal with this kind of issue. So we decided to leave it for now and come up with a better solution to this later in the future. Also, construct which has multiple attachment point are not handled properly. As we can see, this argument comment can be written before this in-out headers, or it can be written after it too. So we kind of need some standard way to say that, okay, this comment inside these type of construct should be written in a certain way. It should be either before or after it. So this project is still in its nascent phase, and so and a lot of work needs to be done still. So a good thing is I'm planning on continuing the project even after now that GSoC has ended, and a lot of work and a lot of polishing needs to be done. As I've already discussed, the problem of attachment of comments to multiple nodes in the last slide, we need to come up with some standard set of opinionated formatting rules and guidelines by taking community from the feedback from the community. I'm planning on starting a thread about it soon for a discussion on this matter in the P4 issue section. Now, as we have already seen the problem that our current implementation has, we need to come up with more ways, sophisticated way to handle this free floating comment and construct with multiple attachment points. A support for common formatting options like line wrapping, indentation, and all is still left and needs to be done. I'm also planning on providing a config option like every other formatter that provides, for example, Clang or Prettier. I would especially like to thank Billy and Fabian, my mentors for the project. They are some of the best people I've had the opportunity to work with. I honestly asked a lot of dumb questions, and they were very happy to entertain it. I'm really grateful for that. Mm, yeah, I guess that's it from my side. If you have any questions, feel free to say them. Thanks.
Okay, so I see a question from Vladimir. So the question is, preserving the comments is definitely important. However, during the compilation process, the IR gets significantly transformed. How will the formatter deal with those issues?
Okay, so what we're doing is we are sort of doing this operation of attachment of comments to nodes right after the passing is done. So before any of the front end passes takes place, we are doing just before any of other passes take place. So it is the passes, different passes that changes the IR nodes, right? So we are currently ignoring those and just doing it after the passing just happens. Also, this handling of comment through a sitemap is kind of like a makeshift solution for now. We're still planning and looking for a better ways to do this. So yeah.
So does that answer your question, Vladimir?
Not exactly, I think, because what happens is the main idea, right, is that we ingest the P4 program with the comments, and then obviously we would like to output the different transformation of that program, I would imagine, unless I misunderstand the goal of the project, right? And so we would like, when we output the program after the transformation, to that's when we would like to preserve the comments. And so that's precisely when the nodes will start getting modified, deleted, rearranged, all that kind of stuff, right? So that was the reason for my question.
Okay. So we still this was just a sort of like a prototype which we developed. Uh, so the issue is that we are attaching these comments in kind of like a side map, right? So after the IR node gets changed or modified, deleted, as you said, uh, it would not preserve the position of the comments. Is that what you're implying? If I'm getting that
Well,
right?
so if, for example, a node to which a comment is attached is replaced with another node or a set of nodes, right? Will the comments be even preserved, or they will go away because the original node is gone?
Okay.
So maybe I can
I
help clarify a little bit here. I think to preserve comments throughout the compiler transformations is currently not within our scope. What we are trying to do for now is not to apply any further IR transformations. We just want to have a formatter that takes in an input P4 program and just right after the parser, and then try to output it with comments without applying any further transformations.
I
But
see.
I imagine there could be refactoring tools that might need to transform the IRs that might be left as future work.
I see. Okay, so yeah, and I think Katie just clarified in the comments. So, but I guys certainly suggest you look at this because that's what people really need to do in the course of their practical work. They often print the IR after the transformations, and that's when the lack of comment is is really makes things difficult. So, please, thanks. Great
Yeah,
spot.
we were just sort of getting started. I'm still planning on continuing it, so we will look into it, look for better algorithms and such. This was just to bootstrap the project, sort of thing, right?
If no additional questions, then thank you, Nitish and Billy. So we're ready for our next speaker, Rupesh.
So the project have taken in the GSoC period is PMB to PNS support. And my name is Rupesh Shilka, and the mentors for this project are Billy Dong and Haritantra. So my name is Rupesh Shilka. I'm an integrated master student in computer science at University of Hyderabad. So my main focus areas are AML, cloud computing, and networking. I recently joined as software engineer at Marvel, and this is my GitHub link, and my interests are badminton and volleyball. And this is about mine. And so coming to the project, the what the NICs are Recently the use cases for the NICs have been increasing a lot, and P4 community has developed an architecture for the NICs called portable NIC architecture. But we still don't have any implementation for the NIC in either in the software or in the hardware. So if we take the goal of this project is to add a support for the PNA in the software. Here we have chosen the software simulator BMV2. So currently BMV2 only has support for V1 model and PSA model. It doesn't have a support for PNA yet. So the the objective of this project is to at least add a minimal support of the PNA into both BMV2 and P4 compiler. So the goals are like to create a new target in the BMV2 that supports the PNA, and to create a new backend in the P4 compiler that supports the PNA for the BMV2's new PNA target. And also the other goal is to design and create test cases to ensure that our new PNA target is working correctly. So by doing implementation, the contributions have been made to both BMV2 GitHub repository and the P4C GitHub repository. In the BMV2, we have created a basic PNN, a new target called PNN target with all the extents like meter, counter, register, internet checksum, etc. And we also added a test case to validate whether the of what happens is like if we give a PNA P4 program to the P4C, the P4C will generate a PNA JSON file. So we have created a test case in the BMV2 to check whether our BMV2 target, BMV2 PNA target, are able to load the PNA JSON files or not. So that's the test case we added. And the other the binary we have. The binary for the new PNA target is PNA underscore NIC. So we can now the users can if anyone wants to try the PNA binary, they can just clone the repository and just follow the installation steps mentioned in the repo. They will be the PNA binary will be available to them. And the contributions made to the P4C GitHub repository are created a new P4C backend for the PNA target. So while creating a new P4C backend, we have made two significant changes to the current source code in the P4C. One is like both PSA and PNA both have a lot of common components. So if we just simply add a new backend for the PNA, there will be a lot of duplicate code between PSA and PNA. So what we did is we modularized the code and we created a common code base, which we call portable common. And we then inherited the both PSA components, and both PSA and PNA components have started inheriting from the portable common components. And another major change that we made is like there are classes called program structure class and a code generator class for so what the program structure class does is it defines all the structures and the information that is needed for the generation of the P4C generation of the code. And the code generator class has all the functionalities to create the output structure. So we have merged this both program structure and code generator class into one class. And another is the P4 community has developed a specification file addressing the PNA architecture, and we have included that. And we have made after all these changes, the binary we have created for the new P4C backend that supports the PNA is P4C P4C-BM2-PNA. So to use the new P4C backend, the user can just clone the GitHub repository and follow the installation instructions that mentioned in the repo. They will get the new P4C backend binary. And next, the demo is So there is also another repository in the P4 called PNA. There is a repository called PNA in the P4 land, which have all the example PNA programs. So I have taken one simple program from that repository to test whether our new target is working or not. So I have taken a program called PNA demo L2 one table .p4. I have compiled it with our new P4C backend, and then the next step we started the new BMV2 target. So the image shows what happened of image shows that we are starting the PNN target. Then we have the what the P4 program does. What the P4 program does is it has a table called L2 forward. It takes whenever the packet comes, it takes the destination MAC address of that packet, and according to the destination MAC address, it sends the packets to appropriate ports mentioned in the P4 table. So using PNN CLI, we have populated the L2 forward table. Then this is the output of what it looked like when we populated the table. And then we tried to send the packets from one interface and listened on another interface to check whether our new PNN target has successfully sending the packets to other interface or not. So, like in you see, in the first image, we are trying to send from interface from one interface, and in the second image, we are trying to listen on another interface where we can get the packet that we have sent from the first interface. So our PNN target is able to send this packets successfully. So the basic for our new target is able to do the basic forwarding successfully between the interfaces. Then the future work is like there are still few standard PNA features that are yet to be implemented in our new PNA target, such as recirculation, dropping, differentiate, and another to differentiate the host and network interfaces. I'm still planning. I'm still planning to do these. I'm still planning to implement these features, and some other experimental PNA features. These are these are the PNA use cases that needs to be implemented. So like IPsec encryption, decryption, and RSS and TCP segmentation offloading. These are some experimental PNA features. So these are need to be implemented. My email address is rupeshchilka@gmail.com. I have given two links. These are the GitHub repos issue links where all the discussion happened while developing these while contributing to the GitHub repository BMB2 and P4C, and we are open to collaboration from everyone, and yeah. So lastly, I would like to thank my mentors Billy Dong and Haritantri. So they're really helpful for me. Like really helpful whenever I ask any question. They are very prompt and they are really nice. And as my mentors, the community has also helped me a lot um, while developing. So I would like to thank everyone in the P4 community everyone is very supportive. Yeah, thank you. I'm open to questions.
Yeah, maybe I have a question. So for the yet to be implemented standard PNA features, do you foresee any challenges in implementing them, or is it just a matter of taking more time to implement them?
Like recirculation and dropping and those other things, I don't see
Yes.
any challenges there. But I've checked the source code I've tried to implement the 1 minute, I will share this one. Yeah. So like in the third point, like differentiation between host and network interfaces. So while I try to implement the third point to differentiate the host and network interfaces. So what happened is currently we are not the PNN target for inherits from the switch class. because the NIC and switch doesn't have any much differences as of now. And while in the switch class there is a to store the interfaces, it just uses a one class called interface list. But for our use case, we need two we need to differentiate host, and we need to use two classes, or we need to instantiate two variables. So then we may have to change the source code of the switch class there. So if you have to change the source code of switch class, there might break some the existing code, or we can directly inherit a NIC. We can start a NIC class above the switch, and then we can start inheriting the PNN target from the NIC itself. Sorry if I made you confused.
Yeah, thanks, Rupesh. And any other questions for Rupesh? Yeah, I don't see any. Maybe we can move on to the next presentation.
Okay, thank you, Rupesh and Billy. Stanislav, we're ready for your presentation.
Yes, thank you, Denise. So, hey everyone, my name is Stanislav, and I'm super excited to share with you my results of my Summer of Code project. But before we get into it, I just wanted to say huge thanks to both of my mentors, Radostin Stojano and Davide Scano, for all the support during the project. It definitely wouldn't have been possible without you guys. So, just a short introduction of me. I am a computer science student at Technical University of Berlin doing my master's. And next to that, I work as a part-time software engineer at Cresta. And in general, I'm interested, obviously, in distributed systems and networking. So I want to first motivate the project. Why did we decide to spend energy and effort into this? So Kubernetes supports container checkpointing as a beta feature in the kubelet API. And that allows us to create a container checkpoint in one pod and restore this container in another pod, possibly on another node as well. However, the problem is that when we have established TCP connections to this container, those would get dropped because the networking changes are not reflected. So our idea was to use a P4-based switch to dynamically insert match action table entries after migration to essentially keep the TCP connection alive. To illustrate this, I created a little bit of a diagram. So here we have a client connecting to the P4 switch and two nodes on the other side. There's a container running on node 1, and the client establishes a TCP connection to this node. However, for some reason, for resource reasons or load balancing, whatever, we want to migrate this container to node 2. So after we have done that, this container, this connection is going nowhere, basically, to node 1, where the container is not running anymore. However, if we update the match action tables in this P4 switch, the traffic gets rerouted to node 2, and we can proceed with the connection as normal, with the client experiencing some downtime, minimal or not, we will see, right? So we developed this project very incrementally. And first we started with a very simple use case, which is process migration on Linux. And just to explain very shortly how checkpoint and restore works on Linux, usually, I mean, the best tool usually is to use a CREU, which is checkpoint restore and user space. And this tool creates a checkpoint of a Linux process, including socket information. And when we restore this process somewhere else on another node or another network namespace, the connection is immediately, or the socket is immediately in established state. One issue we faced here is that when the IP address changes, we needed to rewrite this IP address in the checkpoint file. Just very shortly, this topology we used is basically multiple network namespaces for different hosts, where we connected each namespace with a switch using virtual Ethernet pairs. And many of you will think that this is a very similar functionality to what containers do, and that's exactly what we thought as well. And which brings us a little bit closer to the Kubernetes integration, which is we used Podman for creating these networks and the containers inside of pods. And then both Podman and Docker use the same tool Crew to create these container checkpoints. And essentially, we did the same flow with migrating between different pods in different networks. I have prepared a little bit of a demo for this example, and it's a little bit more trivial than the ones before, the examples before. And we have a Redis in-memory database running on host 2, which we want to migrate to host 3. Again, these are 3 different networks, 1, 2, 3, which are created using Podman. And basically, we have on host 1, we have 3 components running. The backend basically exposes an endpoint which fetches some data from the Redis database. The front end fetches data from the backend, which displays it a bit, and the producer generates some data for the database for us to see, which is very simple. It's just a counter in this case. You might think this is a stupid example, but it's just meant to simulate that we have 2 TCP connections from the backend and from the producer running to the Redis database. And very shortly, if this works, yes. I hope you can see a list a little bit, but I'll describe it as well. So we have 3 terminals running. And on the left, we can see our controller, which has already programmed our P4 switch, BMV2 switch in this case. And here in the middle, we can see our client, basically, which the front end, which is fetching data from the backend, and we see the value is increasing and the uptime as well. This is uptime and connected clients of the Redis database. This comes from that. And we check the logs. On host 2, we have the database running. On host 3, there is nothing yet. So now we execute our migration script. Also, we change the IP address, as you can see here. Hopefully you can see it. And here we can see there's absolutely no downtime in this case, and the client keeps fetching data. However, as we can see from the logs, the client, the Redis database was already running on host 3. So finally, we get to exploring Kubernetes a bit in this case. And yeah, as we already mentioned, this is a beta feature, the container checkpoint in the Kubelet API. And under the hood, if we use the container runtime interface Creo, that uses Creo again to create these container checkpoints, right? So first off, there are many problems with this because the container checkpointing in Kubernetes is not meant for live migration, it's meant for forensic purposes. But the main 2 issues we identified immediately was it's a very manual process. The container migration, from the checkpointing to the restore. And also, how do we include the BMV2 switch in Kubernetes in the whole ecosystem and do it in a way that's reasonable? So the first problem, we wrote a script also based on some resources that are already provided by the folks at Kubernetes to create basically the checkpoint by calling the kubelet API. But then this is a little bit different here. We have to build an OCI container image from the checkpoint. And also we need to push the image to a local container registry or a hosted one, but that's slower, obviously. And then we need to also edit the manifest to use this image, reapply the manifest, and wait for the Kubernetes system to schedule this container, right? And problem 2 was, yeah, how do we include the BMV2 switch here, right? To actually reroute our traffic to the correct container. First solution we explored was using the tool MetalLB or software MetalLB, I guess, to route traffic, which basically in L2 mode route traffic to a specific node where we could extend kubeproxy to use the BMV2 switch and this would allow us to load balance between different nodes in a multi-node cluster. The second option is to build a CNI plugin in a way similar to KubeRouter to load balance traffic between pods on each node, on one node, using BMV2. So because of the resources available in the project and the time, and also we didn't have a multi-node cluster, we decided to run with option 2. And this included to containerize the BMV2 switch and the controller, which was pretty straightforward, provided the resources from the P4 community. And the harder part was to write a custom CNI plugin, which would attach container interfaces to the BMV2 switch as ports, essentially acting as a bridge, and then updating the match action tables, firstly for adding the containers so that the switch load balances between different pods or containers. And also when we migrate from one pod to the other, then update that this node has changed, right? This IP has changed. And similar to KubeRouter, that's why I mentioned it, deployed everything as a daemon set. So unfortunately, again, because of the time left, we didn't get to finish all of this, but most of it is done. Some details are left, and definitely work is continued after the project. And that being said, there's a lot of exciting stuff left to do as well. Firstly, to deploy the load balancer on a Tofino switch, for example, or on a SmartNIC, which would allow us to easily, or probably not easily, but realistically do load balancing and this updating of the routing tables on a multi-node Kubernetes cluster, on a actual metal cluster, right? Bare metal. And then, as I mentioned, as you noticed probably, the migration process is very lengthy, and it takes a lot of time to create an OCI image, to push it to a registry, and to pull that again, and blah, blah, blah. So this process definitely needs to be optimized for live migration. So yeah, that's about it from me. Last thing I want to say is a huge thank you to the whole P4 community for doing Summer of Code in general. I think it's very worthwhile, and I appreciate all of you guys that you spent your free time on this as well. Thanks. And please ask any question.
I have two questions here.
Yes.
My first question would be like, as you mentioned, right, you have used the Podman, right? So have you tried
Yes.
this in a in like a mini cube or some kind of
Yeah.
Kubernetes like environment where we have 3-node clusters of worker nodes and all, like with the
Yes. So we deployed a single node cluster just running on a normal computer, and we utilized this was done using kubeadm just normally, and we utilized here the cryo runtime container runtime interface to create these checkpoints basically. And yeah, a lot of functionality was tested already using this CNI plugin. But again, so the full migration is not fully finished yet.
Okay. But what is our roadmap? That is my second question. Like, what is our roadmap to take it further? Like, are we planning to have a multi-node cluster, then we'll try out with multiple nodes for migration, or how it is like?
Yes. So firstly, I want to finish the work on the single node thing, basically running as a daemon set on each node. And then there are plans already I discussed with my university to essentially use a Tofino 2 switch and use their multi-node cluster, bare metal cluster they have, and then run experiments on that. And definitely, of course, I will publish all the findings and all the resources in the same repository.
Okay, so are we planning to extend the BMV2 to support this multi-node, or we are going for a Tofino base to make this as a multi-node, like for multi-node?
My plan was just to use the standard BMV2 switch using the CNI plugin on single node and then use Tofino 2 on multi-node. But of course, I'm open to opportunities. There's a lot of exciting stuff to do still.
Okay, good. Okay, thank you.
Yeah, no problem. And also, of course, open to any suggestion on the repo, pull request, whatever. Yeah.
Yeah, can we get a link of the repository? Like, is there in the...
Yes, it's in the slides, but I think it was written up. Yeah. No. Okay, I can just send it in chat. Maybe that's easier.
Yeah, I'll be more than happy to see like what best can be done. Thank you so much. I think it was a really nice presentation.
Thank you.
We have a question from Vladimir. So can you describe the details of the data plane program and any challenges there? Can you answer to this question, please?
Yes, of course. So the data plane program is a very simple P4 load balancing program, where initially we accounted with only one client in the system and then a multi-node, basically load balancing, like multiple nodes for load balancing. And this is essentially the example program from the P4 tutorial repository, which we extended for our purpose, right? So it includes a group table and then the next hop table and also the egress tables per port, right? Does that answer the question?
Yeah.
So,
yes.
I can find it. I also posted the link now. Finally found the chat. Yeah. Any more questions? I guess not. Then thank you very much to everyone.
Okay. Thank you, everyone, for joining us today. And thank you certainly to our speakers, as well as the P4 community mentors who participated in the Google Summer of Code.